Okay, let's review for the test on Chapter 10. So number 11 says, find the square root. This one's actually bigger than you have to have memorized, but the square root of 169 is 13. So you do have to have the ones memorized that go up through 144. So you need to know the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, and so on. If you look at your notes on section 10.1, it has all those listed out there for you. You just have to know 1 through 144. That's 1 through 12 squared, basically. Okay, so 12 is one you should be able to do without a calculator. We do negative square root of 25. So the negative sign just stays, and the square root of 25 is 5. So just a reminder, negatives outside the square root are fine. If you had a negative inside the square root, you'd have no solution. Okay, 13, we have plus or minus the square root of 1. So you just keep the plus or minus, and the square root of 1 is 1. Okay, 15, we're also doing without a calculator. It just says to estimate. So we're trying to think, okay, what perfect square is this closest to? So the square root of 15, that's close to the square root of 16. The square root of 16 is 4, so that will be our estimate, 4. 16, we get negative square root of 52. So we're thinking, okay, what perfect square is that closest to? I'm going to keep the negative sign, but that's closest to 49, and the square root of 49 is 7. 17, negative square root of 90. Okay, so that's actually pretty close to both 81 and 100, but it's a little closer at 81. I won't have one that's that close to two of them because it's 9 away from 81. It's 10 away from 100. Mine will all be closer than that. But anyway, it's closest to 81, and the square root of 81 is 9, so our answer would be negative 9. Okay, number 20. Says name all the sets of numbers to which each real number belongs. So 18. So 18 is a whole number because it's no decimals, no fractions, and it's positive, so it's whole. That means it's also an integer. It's also rational. Because if you're a whole number, you're also all the others. Well, all of those other two, I mean. And I will have them listed, like I'll have whole, integer, rational, and irrational listed for you on the quiz, just like it is in the instructions in the book for this. So I'll have those listed for you. You'll just have to know what they mean. Okay, 21 is 6 over 11. Okay, well that's not a whole number. If you do 6 over 11 in your calculator, that's not a whole number. It's not an integer either. So that means it's just rational. Now it's rational because it's a fraction. So everything we think of as a whole number, which is positive or negative, is rational. Fractions are rational. And any decimals that end or have a repeating pattern are rational. But 22, that's the square root of 74, that's not a perfect square. Unless it's a perfect square, square roots are irrational. The only things you have to remember are irrational are square roots that aren't perfect, like square root of 25, that's 5. So that would be all these things. But square root of 74 doesn't come out to a whole number, so this is irrational. Pi is also irrational. 23 is 4.5 repeating. So this is a decimal, and that means repeating. So any decimal with a repeating pattern is rational. So just remember, whole numbers can only be 0 and positive. Integers can be positive, 0, or negative. Rational is all of those plus fractions and decimals that end or have a repeating pattern. Okay, 24, we're comparing 6.25 repeating to the square root of 39. And you will be allowed to use your calculator on that. So this one's already a decimal. So let's plug in the square root of 39 and see what it is as a decimal. So the square root, you hit second, and you hit the squared button. The square root's right up there. So the square root of 39 is 6.24. So 6.25 is just a little bigger than 6.24, so we would put greater than right here. 25, we're comparing negative square root of 70 and negative 8 1/5. So negative square root of 70 gives us negative 8.36. And then 8 1/5, we do 8 plus 1 over 5. We get 8.2, it's negative 8.2. So you have to remember with negatives, things are backwards. So normally we think 8.3 is bigger than 8.2, but things are in reverse with negatives. So this is actually less than this one, because negative 8.3 is farther down than negative 8.2. Okay, 28, we are solving for D. So to get rid of the squared, we have to take the square root. And whenever you take a square root of a variable, you have to put plus or minus in front. And the square root of 100 is 10. 29, we have 4y squared equals 5.76. So notice the difference between these two. This one just had the squared. There was nothing else with the d except the squared. This one has the squared and the coefficient of 4. So we have two steps on this one. Before we take the square root to get rid of the squared, we have to divide both sides by 4. So 5.76 divided by 4 is 1.44. So y squared equals 1.44. Now that I've gotten rid of that 4, I can get rid of the squared by taking the square root of both sides. So I do the square root of 1.44, and I have to do plus or minus 1.2. Okay, I know you'll see the answers, but I think it'll be easiest for me to explain just by showing you these. 31. So to get the missing angle, you got to remember with angles, and this is some people confuse all the time, with angles, we're dealing with 180 degrees. Now when we get down to the next section, we're dealing with sides. That's when you do the Pythagorean theorem. So right now on these, we need to think about 180. So we know all three angles have to add up to 180 degrees. So I'll subtract the two that I do know, and that gives me the measure of the angle we don't know, 45. So all three of those angles are less than 90. That makes it acute. None of the sides are marked as congruent, so it's scalene. 32, same process. We'll do 180 minus the two they tell us, which are 63 and 63. So the missing angle is 54 degrees. All of them are less than 90, so it's acute. You can see those two red marks, so two sides are marked as congruent. That means it's isosceles. So when no sides are congruent, it's scalene. When two sides are congruent, it's isosceles. Okay, on 33, we do 180 minus 45 minus, don't forget, they actually are telling us what that's equal to. That square right there means it's 90-degree angle. It's a right angle. So the missing angle is 45 degrees. Because of that right angle, it's a right triangle. You just have to have one right angle and it becomes a right triangle. And two sides are marked as congruent. That means isosceles. 34, we do 180 minus 60 minus 25. So the missing angle is 95 degrees. That's bigger than 90. If just one angle is bigger than 90, we call the triangle obtuse. None of the sides are marked congruent, so it's scalene. 35, all the sides are marked as congruent. That means it's equilateral. And These two always go together. If it's equilateral, it's also equiangular, meaning if all the sides are congruent, also all the angles are congruent. Okay, now as we get down to this next section, 36 through 39, we're dealing with the Pythagorean theorem. So that's a squared plus b squared equals c squared. A squared plus b squared equals c squared. You'll see that in writing in just a second. Actually, it's right here, now that I look at it. You do have to have that formula memorized. This is what you use to find the sides of a right triangle. To find angles, you do the 180 thing. To do sides, you do the Pythagorean theorem. So right here, C is the one opposite the hypotenuse. No, sorry, C is the hypotenuse, which is opposite the right angle. So if I drew a line out from the right angle, that tells me what C is. That's the one that goes by itself. The other two are A and B, and they're added together. So I'll plug in 30 for A, 40 for B. So I'd get 30 squared plus 40 squared equals C squared. Then I just type 30 squared plus 40 squared in the calculator, and I get 2,500. Then to get rid of the squared, I take the square root of both sides. So remember, square root, you hit second, then the squared button, 2,500. We get 50. So C is equal to 50. Okay, let's look at 37. 37, again, it's the hypotenuse that we don't know because that's the one across in the right angle. So we'll plug in 5 for A and 6 for B and then try to solve for C. So 5 squared plus 6 squared equals C squared. So C squared's already by itself, so I'll just add 5 squared plus 6 squared in the calculator, get 61. Then I'll take the square root of both sides to get rid of the squared. So I get 7.8 as my C. Okay, now on 38, we're also trying to find C. So we plug in 20 for A and plug in 7 for B. So we do 20 squared plus 7 squared. That's 449. Then I take the square root of both sides. We get 21.2 equals C. 39, we're looking for C again, so we plug in 34 for A, 15 for B. Filter my numbers there, 34 and 50, yeah. So I plug 34 squared plus 15 squared in the calculator. Gives me 1381. Then to get rid of the squared, I take the square root of both sides. So I do the square root of 1381. I get 37.2 because this 6 tells me to round the 1 up to a 2. So 37.2 is C. Okay, 42, we're doing the distance formula, and we have the points -2, 7, -5, 7. So we do the big square root, and we subtract the x's. -5 minus -2, all squared, plus the second y, 7, minus the first y, 7. And this formula will be provided for you on the board. Minus a negative is plus a positive. -5 plus 2 is -3, and 7 minus 7 is 0. Remember, when you plug this in the calculator, you have to put parentheses around the negative number. So I start a new parenthesis, because this first parenthesis is just for the square root. So the second parenthesis is what I'm doing for -3, then I square it, plus 0 squared, hit enter, and I get 3. So the distance between those 2 points is 3. 43, we have 9, -5, and 0, 4. So we do a big old square root. We subtract the x's, so I get 0 minus 9, because that's an x and that's an x, squared, plus 4 minus -5 squared. Oops, sorry, squared should go right there. 0 minus 9 is -9. Minus a negative, same as plus a positive, so 4 plus 5 is +9 squared. So again, on the negatives, you have to put parentheses around them. On the positive, it's okay if you do, it's okay if you don't. But on the negative, you have to put parentheses around it. So we get the square root, parenthesis, -9, close the parenthesis squared, plus 9 squared. And I get 12.7. I'm going to skip 46. I'm going to tell you there's nothing like that on the test, so save us some time and just stop there.